Okay, here we go. Last lesson, absolute value inequalities. All right, so we just got done with absolute value equations. Now we have absolute value inequalities. All right, how are you going to solve them? It's going to start the same way. ISO the ab. Isolate the absolute value. ISO the ab. But the next part is then read the symbol. Then read the symbol. Okay. Now, the ab has to be isolated. The ab has to be on the left and the number on the right. That is the condition. Just like you guys goof it up when you graph 7 greater than x. And I tell you to put the x on the left and the number on the right so that you graph x less than 7 and get it correct. Again, to properly read the inequality symbol, you need the absolute value on the left and the number on the right. So ISO the ab on the left, then read the symbol. All right, here's how it goes. If it's a less than or equal to, it is a conjunction. Another reason why we just learned conjunctions. See, an absolute value inequality is either going to be a conjunction or a disjunction. Conjunction or a disjunction. Okay, we can do that. We know how to do conjunctions and disjunctions, all right? At least we're getting close to knowing how to do conjunctions and disjunctions. So look, your mind, when you look at an absolute value inequality, you have to immediately be thinking conjunction, disjunction. Absolute value inequalities are conjunctions or disjunctions. If you don't think that, then you're not going to get it correct. Just like on the quiz for, I think it was 7 and 8, the bottom there, when you saw the word and, you didn't think conjunction. And when you saw the word or, your brain didn't say disjunction. And you missed those two. So again, when you see an absolute value inequality, you got to say, conjunction or disjunction. Let me ISO the ab and figure out which one it is. And away you go. Now, do you have to memorize less than or equal to is a conjunction, greater than or equal to is a disjunction? No, but that's the easiest way to do it. There is a way to read your graph. I'll show you that, but this is far easier. Far easier. And it's kind of, in my mind, in alphabetical order. C comes before D, and less than, then greater than. Left to right. I don't know, in my brain. But you can't mix those up, obviously. You'll be in trouble. Right? If you get them backwards, then you're going to miss. Okay. I'm assuming no one has a question because I don't see any hands yet. Because I think you know what that means. Now let's see if we can apply it. Okay. Let's take a look at the first example. And to help you out, we'll do conjunctions first. Now again, I'm helping you because I'm telling you it's a conjunction. You get on a quiz or test, you got to figure that out yourself. Really, right now, we don't even know yet it's a conjunction looking at the original, although we have an idea. So we got to ISO the ab. You know how to do that, right? You know how to do that. Let me see. Adam, what do you want to do to ISO the ab? I agree. So Adam does this, and we get the absolute value of x plus 1 is less than or equal to 5. Is our ab ISO'd? Yes. What does our inequality symbol tell us? Tells us it's a conjunction. Less than or equal to are conjunctions. Good. I need to know that information. I need to know that information. Now, I really don't want to confuse you, but I need to show you two methods of finishing off the absolute value. And really, in years past, I started off teaching a certain method and stuck with it. But again, I know the book teaches a different way, and what happens with students is, for some reason, they get home and they don't look at their notes. They instead grab their book and look in the book, and then the book shows it a little bit different way, and then they're really confused. Why they don't look at their notes, I have no idea. My job as a teacher is to give you notes to help you through the lesson, but they don't look at the notes. So I've decided to show you both ways. And I actually changed the way I teach the absolute value equations. But anyhow, all right. All that said, when you see an absolute value equation, you know there are two solutions. When you see an absolute value inequality, and let's go back up here, let's squeeze in. If I'd have been thinking, I'd have had this in your original. Let's put a little asterisk here and make sure you understand. Remember, a conjunction and a disjunction means it's a compound inequality, meaning there's how many inequalities? Two. So I'm going to stick that right here. Two inequalities. Right? The two inequalities you read as a conjunction or disjunction, right? Okay. So how do you finish this? First one. Remove the absolute value and solve just as you would any inequality. Good. That's just like we did, right? Easy. We did that for equations. The only difference now, it's an inequality symbol. Okay? Second way. Remove the absolute value. Don't get ahead of me. Put a negative on the other side. And this is what you got to remember using the book's method. My method mathematically takes care of this. The book's method, you have to remember to do it. You have to remember when you stick the negative on the other side to also reverse the inequality symbol. You can think of it as multiplying by a negative, and that might help you to remember to reverse the inequality symbol. But that's the way to get the second inequality. So let me finish this method, and then I'll show you the other way of thinking, okay? So let's go through on the left. We'll add a negative 1 to both sides. And I get x less than or equal to 4. So I'm going to graph that, because it's a conjunction, and I want to be able to figure out the solution. Dot over the 4, arrow to the left. Do you concur? I'm going to do the other one in blue. Let's add a negative 1 to both sides again to isolate the radical. And go to blue here. And this one's done, x less than or equal to, or greater than or equal to negative 6. What does that mean? Dot over the negative 6, arrow to the right. Somebody read the conjunction and tell me what to graph. What do I graph for the conjunction? Go for it, John. Correct. So John read that correctly. He read the intersection. He looked for where there was black and blue. Dot over the negative 6, line all the way to the 4. Okay, underneath, let's do the solution as a math solution. Who can tell me how to write that as a math solution? Thank you guys. You always contribute, and I appreciate that. I'm looking for somebody new. Kirsten, go ahead. Tell me what to write. Correct. So she wrote the big one as it was, put the smaller number in front, and reversed the smaller one's symbol. And that is the exact same thing. This is algebraic answer. The other is the graph solution. Okay. So if I just give you the absolute value inequality, you don't see a graph, you have to remember, hey, this thing's a conjunction. I'm going to give a solution like this. I'm going to graph it so I can read the solution and know what in the world it is. Okay? That's what you're going to do, hopefully. All right, Lauren. Okay, so when I look at my two answers right here, a 4 is bigger than a -6. So I always write that first. Whichever one has the bigger number. And by the way, the symbol will always be pointing that direction, always with the bigger one, for this kind, always. Then I take the smaller number and stick it in front and reverse the symbol of the smaller one. So the one with the biggest number, write that first as it is, smaller number in front, reverse its symbol. The symbols will always go this direction if you do it correctly, always. With the smallest number on the left and the biggest number on the right, always. All right, I don't think I'm going to even show you the other method, just because I'll probably confuse you. I think it's mathematically superior, but if it doesn't help you, it doesn't help you, so I'm going to pass up on it. All right, let's do the next one. Let's do B. So you look at B. Austin, what do you want to do first on this thing? I agree. I'm going to divide the left by -2. I'm going to divide the right by -2. Couldn't do anything else? Couldn't do anything else? Couldn't do anything else? Josh, help him out. Don't forget, whenever multiplying or dividing by a negative quantity, reverse the inequality symbol. Be careful there. Now we end up with the absolute value of n minus 2 less than 10. Absolute value of -2 less than 10. Oh, it's a less than. Less thans are conjunctions. See, don't read the symbol until the ab is isoed. Don't read the symbol until the ab is isoed. Otherwise, you're going to think it's something else. Okay. Finish it. Okay, so that's where you end up, right? Split it up. Remember, the first time, just remove the absolute value. Second time, when you go to put that negative, reverse your symbol. I reverse it right away so I don't forget. Solve them. Going to graph them so we can read the solution. Wyatt, tell me what to graph.
First circle of the -8, and the top circle and the 12 is going on to each other.
Correct. So it's all the values just bigger than 8, just less than 12, correct? All right, somebody raise your hand and tell me how to write this solution. Abby, go ahead. Correct. So she took the larger one, wrote it as it was. 12 is larger than -8. Stuck the -8 in front, reversed its symbol. Okay? How many got that right? Okay, good. Good. Conjunctions. Well, guess what's next? Disjunctions. Now again, I'm separating them for clarity of understanding. Get to a homework, get to a quiz. First thing you got to figure out is it a conjunction? Is it a disjunction? Oh, look at A. Somebody raises your hand and tell me what you'd like to do with A. Andrew, go for it. Uh-huh. Don't want to go that route yet. Don't want to go that route yet. You could do it. You could go that route. As long as you're careful and you're good with what you're doing, you can come out with a solution. But I want to go an easier way. Adriana. I definitely want to put my ab on the left and my number on the right. Now, how do you switch sides of an inequality? We already know this. What do we also have to do? Say it if you know it. You got to swap the symbol. So don't forget that. Swapping sides for an inequality requires you to swap the symbol. Now I read my symbol because the ab is isoed, and I understand it's a disjunction. The way it was originally, you might think, oh, this is a conjunction. It's less than. No, no, no. The ab's not isolated on the left. Now that the ab's isolated on the left, I understand it's a disjunction. Okay. Math is orderly. How many inequalities are we going to have, class? Say it if you know it. 2. Andrew?
Would it still end up as a disjunction if we had it?
If you know it's a disjunction. You have to know, though. You'll have to not worry about the symbol. Solve the 2 inequalities, correctly graph them, then read the solution correctly. So, it's possible, but you got to do all the rest of that correct. So that's why I say this is the easier way. All right, so you know, right, the first one's going to be n plus 3 greater than or equal to 5. Somebody tell me what to write for the second equation. Kaylin? All right, Kaylin reversed her symbol and put a negative on the other side, and that is what you need to do for the second equation. Okay, finish it off. Finish it off. Okay, so you know it's a disjunction, right? So you should have done that. What's the graph? All values less than 8 and all values, how did I get one symbol of 1 and one of that's a less than or equal to? By the way, on these, the symbol will always be the same. All right, I got a less than or equal to -8. I got a greater than or equal to 2. Somebody tell me how to write the solution to this. How to write it. How to write it. Looking for somebody that hasn't said a word today. Eduardo, how do you write that? Okay, Eduardo, whenever you write it like that, it's always the overlapping part. These don't overlap at all. This always gives you a middle part. But the middle is what we don't want, because this is a disjunction. So basically, here's all I need to do. Let me help you out. Eduardo, how do you say all those values? Give me an inequality that says that. Correct. Give me an inequality that says that. To 2, and all you got to do is include the word or, and that's your solution. Okay? And that's your solution. How many got that right all the way to the end? Okay. And again, because some of you still a little shaky on reading and saying your final solution to a disjunction. All right. For time's sake, I'm going to do the next example for you. But engage your brain. Engage your brain. Engage your brain. Okay. I'm going to ISO the ab. I'm going to add a -3 to both sides. And you know what? Would you mind if I also add like terms inside my absolute value? Would that be okay with you? Does that make sense? So I'm going to get a 4x minus 2 inside the absolute value. And I'm going to get a greater than, and be careful, I'm adding a -3 to both sides, so that gives me a 4 on the right. Do you agree? Okay. Then you say, hey, this is a disjunction. I can't get to the top there. There we go. Because it's a greater than. Greater than or equal to or greater thans, when the iso is ab, are disjunctions. Cool, I'm doing a disjunction. Because I read the symbol. Once I isoed the ab, read the symbol. Okay, 2 equations. First one, get rid of the absolute value. Second, Get rid of the absolute value. I'm going to use my red now. Reverse the symbol. Put a negative in front. You end up on the right, 4x minus 2 less than negative 4. And by the way, all you smart people are using your color each time. All you dumb people, and I say dumb because it has nothing to do with your IQ. It has to do with your attitude. You're not using your color, and you're stupid. You're dumb. It's dumb. You're just lazy to switch the color, and it's the very thing you need to see when you look at your notes tonight, or tomorrow night, or Saturday when you're studying, or Sunday night when you're studying for the test. So you look at the color, it pops out at you. Oh yeah, we reversed that symbol when we did that negative, so it sticks in your mind. Okay, sorry to be so tough on you, but tough love is what you need sometimes. All right, left one, add a positive 2 to both sides. 4x greater than 6. Divide both sides by 4. And let me reduce. You know what? Yeah, I'll reduce. 3 halves. Oh no, a fraction. We'll have no idea what to do now. I'm shaking in my boots. Oh, Nelly. All right. Right-hand side. Add a positive 2 to both sides. Now we end up with a negative 2. Divide both sides by 4. We get x less than negative a half. Oh no, another fraction. All right, this is how I do this number line. 0, 1, and 2. That's really all you need. 3 halves is 1 1/2. Circle over the 1 1/2, arrow to the right. Oh, I need a negative 1, don't I? Negative a half. Circle over the negative half, arrow to the left. Hey, isn't this just like what we did a minute ago? Yep. Graph, circle over the negative half, arrow to the right. Solution on the graph, circle over the 1 1/2, which is 3 halves, arrow to the right. How do you say this one? Write the small one first. Negative a half is smaller than 3 halves. Use the word or. Write the big one. X less than negative 1/2 or x greater than 3 halves. X greater than negative half or x greater than 3 halves. Now, I only got a minute here for time's sake. But let me go back to this first one. And let's suppose Andrew went through and he completed what he was going to do it his way. And he correctly got the symbols going the right way, even though his variable was on the opposite side. But he remembered, hey, I know it goes the opposite, and I'll graph it right. And he graphs it right. But he doesn't know whether it's a conjunction or disjunction. How does he figure it out? So we know how to figure it out by the way the symbol goes. What if you don't? All right, don't do this, just watch. Here's how I can find out. I can try a value down here into the original. Negative 10. Negative 10 plus 3 is a negative 7, right? I'm in the absolute value. Absolute value of negative 7 is 7. Is 5 less than or equal to 7? True. Hey, anything true, those are part of the answer. Hey, that part's part of the solution. Oh, let me try a number in here. How about 0? 0 plus 3 is 3. Absolute value of 3 is 3. Is 5 less than or equal to 3? Oh, none of those values work. None of those values are answers. Let me try a value out here. 4. 4 plus 3 is 7. Absolute value of 7 is 7. Is 5 less than or equal to 7? Yeah. Oh, those values are also the answer. It must be these and those. See, that's the way you got to do it if you don't know it's a conjunction or disjunction. You got to read it out that way. And you can do the same thing with a conjunction. Okay, I know a lot of you didn't catch that. That's okay. You don't have to if you'll ISO the ab and read the symbol, right? You don't have to. You'll know it's a conjunction. You'll know it's a disjunction. All right, special case. What if the absolute value is isolated and the other side is a negative? Now, if this was an equation, it would be null set, no solution. But these aren't equations, are they? They're conjunctions and disjunctions. So, first off, you better say, oh, conjunction on this first one. Conjunction. Let's do a real simple example. Let's stick the number 4 there. X less than negative 4. Okay. Solve it. X less than negative 4. That was easy. First equation. Second equation I'll do in blue. X. What am I going to do next? Flip the symbol. And what's minus a minus? So I'm going to do plus in red. I better not confuse you guys. Let me just do minus the minus. Minus, and then the black minus 4. Blue minus 4. There we come on, blue. Right? Which is a plus. Now, everyone will end up in the same scenario. So real simple graph, right? All we need is a negative 4. By the way, this is a positive 4, right? All we need is a negative 4 and a positive 4. Remember, we're doing a conjunction, right? Look at the black one. Circle over the negative 4, arrow to the left. Agreed? Look at the blue one. Circle over the 4, arrow to the right. Agreed? Where do they intersect? What is the solution to every situation for a conjunction like that? It will always equal the null set. Always. Always. Would it matter if it was a less than or equal to? It would not matter. Those would just be dots, right? And it would still be no intersection. Less than or equal to does not matter. There's no intersection. And it's a conjunction. And if they don't intersect, it's the null set. Let's take a look at a disjunction. Disjunction. All right, again, box that in green. I don't want to obliterate it so you can still see the pattern. But here's the point. You iso the ab, and the opposite starts out negative, right? The other side's negative. That's the condition. Look on the left. You iso the ab. It's a conjunction, and it's negative. You always get the null set. You iso the ab. It's a disjunction, and it's negative. Maybe some of you can think of what the answer might always be. Don't say it, though. Don't say it. Maybe you can think of it ahead of time. Because math is orderly. All right, so let's do an example. Let's go with negative 4 again. Okay, so let's suppose when we iso the ab, we had a negative 4. So again, the first time we're going to remove the absolute value. That's all you get. Second time, I'm going to do it in blue. I'm going to remove the absolute value. I'm going to reverse the inequality symbol. And again, I get a negative 4, right? For a solution of positive 4. Do you agree? All right, I'm going to go a little to the right here. We just need a little itty-bitty number line. Again, our numbers are negative 4 and 4. But look what happens to our disjunction. Black one. Circle over the negative 4, arrow to the right. Blue one. Circle over the 4, arrow to the left. How in the world did that blue turn green? All right, if you think you know the answer, I want you to say it on the count of 3. 1, 2, 3. It is all the real numbers. And if we were to graph it, we would graph the whole line, right? Always. It's always all the real numbers. When you iso the ab, it's a disjunction, and the other side's negative to begin with. Not when you're splitting it up to begin with, before you ever try to get the two inequalities. All right, a little bit there. Try to get it settled out tonight. We'll review tomorrow in class all day. Test on Monday.